Hello everyone. Today we start the series of the solutions of the questions for the financial mathematics and principles, starting from the seminar 2. I'll be recording with step-by-step solutions of each question separately, starting from question 2.1. Okay, let's get into it. And we'll be solving question 2.1, where we have to multiply two matrices, but first we have to transpose the matrix A. Let me simply copy what we have so far. Okay, matrix A is equal to, okay, 0.05, 0.02, 0.06. This is basically the first column. The second column, 0.03. 0.04, 0.01. Okay, we have matrix A, and our first task is to find the transpose of the matrix A. Let's find A transpose. This is how we write it. AT is equal to, what's the definition of the transpose of the matrix? It's the change of the rows by columns. For example, if the size of the A matrix it's 3 by 2, 3 rows and 2 columns, the A transpose should be 2 rows and 3 columns, like we can show it. We have the rule right and down approach. What is that? From the matrix A, I take my first row and put it as my first column in a transpose. The matrix A transpose also starts with 0.05, but another element 0.03 will not be to the right of it, but it will be to the down of it, 0.03. Somewhere here. Okay, exactly the same thing with other rows. I take my second row and put it as a second column. Then I'll take my third row and put it as a third column. Okay, let's do with the second row of the matrix A, and to locate the numbers. Locate the numbers as a column in the matrix A transpose. And of course, the third one. I have 0.06. And 0.01. Then, according to the questions, they are asking to multiply transpose of A by B. Here, they are saying A transpose needs to be multiplied by B. since they are asking the product. Product means the multiplication of them. Now let's copy the matrix B next to A transpose that we found. Here I'm just copying the matrix B. It is 0.5. 0.3, 0.2. Then 0.3. Then 0.4. 0.7. Okay, then I have to multiply them. But before multiplication, we have to pay attention whether we can multiply these two matrices or not. There is a rule regarding the size of the matrices which allows us to multiply these matrices or no. What is the size of the matrix A transpose? It is we call number of rows first, then number of columns. We call something like RC. Yes, first number of rows, then number of columns. What is the size of the matrix A transpose? It is how many rows do we have? We have 2 rows. And then I put how many columns do I have? I have 3 columns of matrix A transpose. What about the matrix B? I have 3 rows and 2 columns. 2 columns. And the rule says that the number of columns of the first matrix, which is 3, should be exactly the same with the number of rows of the second matrix, matrix B in our case. And this 3, they are equal to each other, which allows us to multiply them. If they are not equal to each other, it's impossible to multiply them. And what would be the resulting matrix size? We take these core border numbers, 2 and 2. The resulting matrix size would be 2 by 2 matrix. 2 by 2 matrix. Okay. And how we multiply? Again, the same rule, right and down approach. Right and down approach. I take my first row from the matrix A transpose and multiply by the first column of the B matrix. Okay, here I am taking the first row of the matrix A and multiply by the first column of the matrix B. The respective numbers would be multiplied by each other and there will be addition. But let's write the general case. What will be our answer? Our answer would be this element, A11 element. Let's say this is not the matrix A, the resulting matrix, let it be to this matrix C. We will have C11 matrix, then C12 matrix. This 1, 1, 1, 2 indicates the position of the element. First row, first column. First row, second column. And here it's the second row of first column position. And finally, the element with a second row and then second column position. Then I can calculate each element separately. For example, C11 element would be equal to, I take the first row from the matrix A transpose, because here in a row position standing 1, in a column positions again 1, I take the first column of the matrix B. I multiply respective numbers. First element with the first one, second element with the second one, and a third element with the third one. Then I just sum them up. It as follows: 0.05 multiplied by 0.5. It is the first element of the matrix B. Then I have the second element of the first row of matrix A transpose, which is 0.02, and multiply by second element of the first column of the matrix B, which is 0.3. Then again addition, now it's times the third element, 0.06. 0.06, and then multiplied by 0.2, the third element of the first column of the matrix B. That's simple arithmetic. In order not to waste our time, you can just look at the answers. It should be 0.043. 0.043. Okay. This is our C11 element. I can put this equation mark here and write down my first answer here, which would be 0.043. With the same logic, I can find remaining 3 elements. Let's do one more C1 and 2 element. What is C1 and 2 element? I again take the first row of the matrix A transpose, but this time I should work with the second column of the B matrix. This is 0.05, 0.05 multiplied by first element of the second row of the matrix B, 0.3 now. Then plus second element, 0.02, multiplied by again second element of the second column of the matrix B is 0.4. Then again plus. I will take the third one, 0.06. And multiply is the third element of the second column of the matrix B, which is 0.3. And the answer should be 0.041. Equal 0.041. This is my 1 and 2 element. It will be located here, 0.041. Yes. Okay. Now we can continue with the remaining two. it is C to one element should be equal to. Now it's a little bit different. I will take the second row now with the second row of the matrix A transpose with the first column of the matrix B. It is 0.03. I don't start with 0.05, but 0.03 is this time because I'm in the second row. And multiply by the first element of the first column of the matrix B, which is 0.5. Then I add second element of the second row of the matrix A, which is 0.04. And then multiply by second element of the first column of the matrix B, which is 0.3. Plus third element 0.01 of the matrix A transpose second uh, row multiplied by the third element of the column 1 of the matrix B, which is 0.2. And this is equal to, again, you can use your calculators and check it. I just take from the answer sheet 0.029. This is my C 2.1 element. I put it here to its position 0.029. Finally, we are in a C2 and 2 element, which is second row of the A transpose matrix multiplied by the second column of the B matrix. Respective elements will be multiplied by themselves, and we just put addition among them. Okay, the first element 0.03. I multiply it by the first element of the second column of the matrix B, which is 0.3. Plus 0.04 second element of the second row of the matrix A transpose multiplied by second element of the second column of matrix B, which is 0.4 itself. And finally, third elements 0.01 multiplied by third element 0.3. And this should be equal to 0.028 according to the answer sheet. But you can double check using your calculators or mental arithmetic skills. Okay, and I will locate the 0.028 to the C2 and 2 position. 0.028. So it looks like 8. Okay, this is how we solve the question 2.1. This was our question 2.1. And this is the answer here. Just the answer is shown, but this is the way of solving. Thank you very much. Stay tuned. More questions coming soon. Thank you very much.